The diameter of the observable universe spans a total of 93 billion light-years across. Within this daunting expanse of starlight and wonder sits the Milky Way galaxy, merely a pinprick of light in comparison. And even smaller still is a humble blue sphere, called Earth, our home. My name is Daniel Danielson, and this is Space Stuff. Wait, Neil, space stuff? Oh, f*** all. Much of the outer solar system is still an enigma, simply due to its prohibitive distance from Earth. Jupiter, for instance, orbits 484 million miles from the Sun, with 10-hour days and a planetary year equivalent to 12 of our own. This gas giant is more than 2.5 times as large as all the other planets in our system combined. We don't have any rockets powerful enough to reach the outer solar system on its own, so in the early days of space exploration... Wait, are we still in the early days of space exploration? It's hardly been any time at all since the moon landing. Do you think we're just stopping there, Neil? What? Like we're just going to stop funding new space missions? Ease off of it? Stop paying attention? The private companies will have to pick up where the government left off? Something like that? Nonsense. Never mind. In the early days of space exploration, scientists calculated how to use Jupiter's intense gravity to slingshot spacecraft further out into space. Full of gaseous hydrogen, helium, and other trace elements, Jupiter's quite like a star that never gained enough mass to cause the gravitational collapse that would trigger ignition. It's uncertain whether therein exists a solid core, but if there is, it couldn't be much bigger than a single Earth. With such a substantial mass, Jupiter's gravitational pull is considerably powerful. The gas giant has more than 75 moons in its orbit within a ring system too faint to be seen from Earth, leaving the rings, the moons, undiscovered until the Voyager mission sent a spacecraft past in 1979. Jupiter's north and south poles are widespread expanses of chaos, and its iconic stripes and swirls are frigid, stormy clouds of ammonia and water floating in the atmosphere. The famous Great Red Spot is a hurricane-like gale the size of 2 Earths, which, like many of Jupiter's storms, has been rotating for centuries. You know, Neil, space seems to be a rather unpleasant place. I can't imagine why we'd be so concerned with exploring it. Everywhere that isn't here just sounds inhospitable. Just an entire galaxy of Helens. Really? Why, Neil, that's simply beautiful. All that, and this is the best script you can write? Oh, come off it, you oversensitive twat. In 1975, physicist Enrico Fermi posed the question: if there have been nearly 14 billion years for an older species of intelligent life to develop, and over 4 billion to find our planet, why haven't they? It's become something of a thought puzzle, prominent in the minds of those interested in the existence of extraterrestrials, whether they be scientists or science fiction writers. Jupiter is now widely believed to have played a role so pivotal in allowing life on Earth to form and flourish that it may be the answer to Fermi's paradox. But within the Milky Way galaxy, only one solar system in every 1,000 has both a Sol-like star and Jupiter-like giant, thinning the odds of contact significantly. Much like a cosmic older brother, Jupiter has been standing guard over Earth for billions of years. Scientists estimate that due to its immense gravity, Jupiter is hit by roughly 8,000 times the amount of space debris as Earth. If not for Jupiter to bear the brunt of the galaxy's salvo, life on our world may never have evolved past the single cell, proving once and for all that the dinosaurs were God's swiftly corrected mistake. Saturn is a massive ball made mostly of hydrogen and helium, so large that the diameter would span 9 Earths. Why are we measuring planets by Earths now, Neil? You can't just make up units of measurement. There are set ones like mile and foot and square light year. It's ridiculous. It's bad enough we refuse to use the metric system. Oh, really? Well, then tell me, Neil, how many bananas away is the moon, huh? Well, how many mustache years does it take to get from Earth to Andromeda? Don't. I'll just read the script. Orbiting at 886 million miles from the Sun, Saturn's volume is more than 760 Earths. I hate you, Neil. Second largest in the system, this gas giant is the last planet visible to the naked eye and is also the only one with a visible system of rings. These 7 complex, well-spaced ringlets of ice and stone are laced with somewhere between 53 and 29 moons. The jury is still out. Really? We don't know how many moons? All our advanced equipment and techniques, or whatever it is we're using to determine how many gas giants there are in how many solar systems in the galaxy. We can't figure out within 30 the number of moons Saturn has. It's absolutely stupid. Saturn's gold and beige bands are created by super-fast winds in the atmosphere and heat rising from the planet's core, pushing clouds up to 1,100 miles per hour. A year on Saturn lasts 29 Earth years, and twice in those 29 years, Saturn appears to be ringless as we view the ring's edge on. Unlike the more stony rings of Uranus and Neptune, Saturn's rings are primarily made of ice, and the rings of all 3 planets are largely comprised of Pluto-like dwarf planets that were once part of the Kuiper Belt during late heavy bombardment, a particularly violent era in our solar system's history which sent a multitude of celestial bodies from the outer solar system inwards. During this period, Neptune and Uranus sucked dwarf planets up whole, where Saturn was only able to strip off the frozen outer layers of celestial objects. The least dense of all planets, Saturn is the only one less dense than water, meaning that if placed in a watery environment under Earth-like conditions, it would float. All right, Neil, I'll admit, that was a bit of fun. Although I can't imagine the logistics that would go into getting a tank of water large enough. Revolving around the Sun at a distance of 1.8 billion light-years, Uranus's 17-hour days... Quiet, Neil. I refuse to argue over the pronunciation. Don't be a child. Uranus's 17-hour days go up against 84-year-long revolutions. The bulk of the ice giant is made of hot, dense materials such as water, methane, and ammonia, above a small rocky core that rests beneath an atmosphere of mostly molecular hydrogen and atomic helium. At first thought to be a comet or star, Uranus was the first planet to be discovered by telescope in 1781, and faced steep judgment from the scientific community, which took 2 years before agreeing it was a planet. Discoverer William Herschel wanted to name it Georgium Sidus, after King George III, but Johann Bode, one of the men whose work confirmed its planet status, insisted on Uranus, the Roman god of the sky. Uranus has 27 moons named after William Shakespeare and Alexander Pope characters, and 13 rings. Uranus's rings are more narrow than the other planets, and we still aren't sure if the rings are all from the same source or not. Where the composition of the other 3 giants' rings are either dust or particulate of all sizes, Uranus's rings are made up exclusively of objects larger than a peony bud. Just why, Neil? Where's the sense in it? All the dust that should have been streaming around the particulate instead filled the typically empty space between the planet's rings. This implies that something is either sweeping all the dust out of the rings, or causing it all to glom together. The exact reason is still unknown. The only planet in our solar system that can't be spotted by the human eye alone, Neptune is 30 times as far from the Sun as Earth, 4.75 light hours as compared to 8 light minutes. Neptune has 16-hour rotations and 165-year revolutions. When the orbits of Neptune and the dwarf planet Pluto cross, Pluto becomes the closer of the two to the Sun. This lasts for 20 years before they cross orbits again, always separated by a minimum of 22 million miles. Wait, dwarf planet?
Yeah, dwarf man.
Well, says who?
No.
Oh, well, all right then. With a 30,000-mile diameter, 60 Earths, God f***ing damn it, could fit inside. It's believed that beneath its icy methane clouds there lies an ocean of super-hot water that's kept from boiling away by the extreme pressure of Neptune's atmosphere. Neptune is the densest of the giant planets, and a burning mix of icy water, methane, and ammonia form a dense fluid that makes up 80% of the planet's mass and envelops a small rocky core. With winds that blow up to 1,200 miles per hour, Neptune has the strongest wind speed of any of the planets in our solar system, though Saturn is a close second. For comparison, Earth's highest hurricane speeds tap out at 250 miles per hour. Because in the grand scheme of things, we're simply not that impressive. These harsh atmospheric winds and freak storms are powered by the extreme heat under the cloud layer, for, despite the ice, it emits more than 2.5 times the amount of heat it receives from the Sun. Neptune has 5 main rings with 14 moons and 4 ring arcs. The arcs are likely young and temporary structures, made of peculiar dirt clumps coated in some carbon-based substance. But what's most fascinating about these arcs is that the laws of motion as we know them indicate that the compositional dust should have fanned out evenly, not accreted in clusters. The best guess scientists have is that the moons Galatia? Screen. The best guess scientists have is that the moon Galatia's gravitational pull might have a stabilizing effect on the arcs and the materials within. But this is mostly speculation. Triton, Neptune's largest moon, is the only large moon in the system with a retrograde orbit around its host planet, suggesting it may be an independent object turned captured satellite. It also has ice volcanoes that spit material 5 miles high, because Earth just doesn't have enough of an inferiority complex.
Why do you think that?
Oh, I don't know, Neil. Maybe because you won't let me stop talking about how many Earths we can fit inside all our neighbors.